Hello everyone, so today we are moving on to our next section, which is 12-2, and this section is about area of circles and sectors. I'll show you everything in a minute. Alright, so let's start off with the area of circles, which is pretty easy. So again, just like normal shape, if I ask you for area of a shape, basically I'm asking you for like how many perfect squares can fit in that shape. That's what it means. So let's say this is a circle. If I ask you for area, it means how much space this whole shape could hold. That's what area is. How do we do it? That's pretty simple. Finding area of a circle, it's pi r squared. So what you need is just the radius times it by pi, and then that's going to be your answer there. Let me show you an example. Pretend there's a circle. Let me just pick a different color. So there's a circle which has a diameter of 32 centimeter long. So 32 centimeter long diameter. So find the area of this circle. So what we need is the radius, not diameter. But diameter is twice as radius. So what would be the diameter length? The radius length. So radius would be half of this diameter length. So 32 divided by 2 is 16 centimeter. Plug it in. So it would be pi 16 square. And you can leave it in pies if you want it, or 16 squared is 256, if I'm not wrong, and times it by pi. And then it's centimeter square. Here you go. So that's how we find area. That's my first example. Now let's move on to the next one. That was finding area of circles. Now finding area of a sector. Area of a sector of a circle. Circle. What does that mean? Before I just asked you for area of the entire circle, right? Now, if I say a sector of the circle, it means I'm just asking you to find area of a slice of the circle. Pretend this is A, this is O, and this is B. We're not talking about distance anymore. It's the area of this entire slice, basically this whole piece. All right, how do we do that? Just like arc length, we started off with logic, right? So same thing works for this one. So first, just think about this. Isn't it the bigger this angle, the bigger the slice would be, right? So it means it's going to carry the same proportion we have for arc length. Let's try understanding. So think about this. If I say this angle, this central angle is the part, what would be the whole for this circle? So central angle, if the central angle is the part, the whole would be entire circle, which is equal to 360 degrees. Okay, so what is this proportion equal to? So this time we're talking about that slice, that entire slice. If the area of this slice, let's just say area of sector. Area of this sector is the part. If this area is the part, what's the whole? Isn't it the whole would be area of the entire circle, which is pi r squared? Here you go. So we're almost there. We already got our equation. Now we just have to simplify for the part we are looking for. So what are we looking for? We are looking for area of this sector. So if I asked you to solve this equation for area of sector, what would you do? I would multiply by pi r squared both sides, right? So if I do that, I can't write it on this side. But anyways, if I multiply both sides by pi r squared, can't actually adjust that. But anyways, pi r squared is going to get canceled out on this side. So finally, your equation is going to be, okay, so area of sector would be equal to the central angle over 360 times it by pi r squared. Here you go. So that's the area equation, area of the sector equation. So let me show you an example. Let's see if I can actually bring in the picture in here. Let me see the last one I had. Okay, so let's see if I can do that. Okay, so this picture, and let's select this. Okay, now, so if I ask you to find area of this whole slice, Same thing. First thing what I need is the central angle. So central angle, remember this angle is same as the angle measure of that arc, right? So it would be 72. So 72 over 360, which is the whole. So times it by pi r. R is the radius, which is 15. So 15. I can't really. So let me write pi 15 and square. Now just multiply straight across, and once you multiply straight across, or you can put in your calculator, you can have 45 pi and centimeter square. You can plug in 3.14 for pi and multiply it out. You could do that, or leave it in pi, is the same thing. Either or, it's fine. Okay. So from this example, let me show you another one just in case. So pretend, let me just erase this whole thing. Pretend, okay, pretend if I ask you for, not for this slice, pretend if I ask you for this slice, the outer one. Do we know the angle for that, first of all? So first thing, what I know is I know the other side, the other angle. So let's find the other angle on the other side. So if I take away 172 from 72 from 180, so it's 108. So I know the central angle on the other side is 108 degrees. If I ask you for that slice, what I would do is, again, my central angle, which is 108, my bad, divided by 360, times it by pi. R is still 15, so 15 square. So if you simplify the whole thing, that would be your answer. Let me just do it for you. It would be 15 times it by 15 and then divided by 360. So it's 67.5 pi centimeter square. So that's how we do it. So again, I repeat, for this area equation, what we need is you just have to have the central angle for that piece divided by 360 times it by pi r square. Plug everything in, and that's how we find the area. All right, so this is all for today. Thank you for watching. Bye-bye, guys.